right? So we're talking about differentiation, which is taking the differential, which is the basis of all calculus. So 2 steps. Multiply the coefficient by the exponent. Okay? Whatever the exponent is, multiply it times the number in front, right? Watch out for your signs. Signs still exist, right? Pay close attention. Okay? Second step. Subtract, whoops, where that whistle came from. Subtract 1 from the exponent.
Like 1 is in the number 1?
Yep.
Why?
Okay?
Why?
Now, I'll explain to you why. Okay? So those are the steps. Now, here's the beauty of having Leibniz and Newton in your past. Before them, people saw patterns, but what they did was they codified it and put it all together so that, and notice that every time you want to find the slope of a line at a particular point, if you just do this, boom, you can find the equation that will give you the slope of the line. Okay? So this is giving you an equation to find the slope of a line. And if it's linear, it actually finds the slope of the line. Okay? But, so what we're doing is we're looking for change, which is slope, right? And change can be measured using this equation. So instead of having to find a bunch of points and do rise over run for all the points and do all the mathematics behind it, if you differentiate, you get an equation that will automatically tell you what the slope is.
So this
How
is
nice is that?
The equation to give you
Exactly.
Okay. What
Okay.
is the differential as like a what's the definition of the differential?
At any given point. So what we'll be doing is finding the derivative. And to do that, to find the derivative of a term, we're just going to multiply the coefficient by the exponent and then subtract 1 from the exponent.
The derivative in relation to.
And the derivative is just what you get when you do differentiation.
Wait, I thought that we got the differential.
It's the same thing.
Oh, okay.
Right, it's just different. I call it derivative, y'all call it differential. Same thinking, same thing. It means the same
I was
thing.
very confused for a moment. I was like,
How do you mean?
Okay?
there's one thing that's not so many things.
Okay? Now, there's one more that I need to talk about. There are 2 special cases. Guys, y'all are wackadoodles today. Here we go. Come on. There are 2 special cases. Come on, guys. 2 special cases. The derivative of any variable, just plain old x, is always 1. And that's straight from the laws of exponents.
Derivative of any variable is
Any variable where it's just like x to the first or y to the first or whatever, that is always 1. So the derivative of y is what? 1. The derivative of a is what? 1.
Oh, wait. It's
Okay.
the derivative of a letter.
Any letter. Any plain old letter. And the reason for that is if you have x to the first, right? And you multiply the times the 1, right? That becomes 1x to the 1 minus 1, which is 1x to the 0, which is 1 times 1, which is 1, right? But you don't want to do all that. You just want to remember that anytime you have just a plain old x or a y or a z or whatever, then the derivative of it is always a 1. The derivative of any number term, remember, which is called a constant, right? The derivative of any constant is always 0. And the reason for that is if you have like the number 7, for example, it has an x at the end of it, but it's x to the 0 power because it's 1, right? And when you multiply 0 times 7, that gives you 0.
Wait.
Because you multiply the exponent on the x times the coefficient. Okay? So this is the y.
Oh, okay. Yes.
Okay? 0 times anything is 0, so you get 0. Right? No, that's the y. Okay? Right? So, everybody? Everybody? What is the derivative of d?
1.
Excellent. What is the derivative of 9?
0.
Good. Okay? So, those are the two special cases.
Wait, I'm kind of confused.
Okay? Page 16. You'll get it. Yeah, you're overthinking it. All right. Here's what I'm going to do is, when we're working in the book, I'm always going to do the even numbered problems, and your homework will always be the what? Odds. And you just make note of the pages we work on, and I'll tell you what pages, and you know you're always doing the odds for that page, right? And so what page are we on right now?
16.
There you go. So, okay? Now, here we are. So first, we'll just start with number 2. It says, the function f of x is equal to x to the second. We want to differentiate or find the derivative of it. So, that means f prime of x, use the correct notation, is equal to, what is the number in front of this x, the coefficient?
1.
A 1. So 2 times 1 is what? 2. X to the 2 minus 1 gives you x to the first. Do you need to write the 1?
Hold on.
So the derivative is 2x. Okay? So, okay. So here's what we started with. So what? First step, multiply the exponent times the coefficient.
Yeah.
Right? So that was 2 times 1 gave us the 2.
Yeah.
Okay? Second, subtract 1 from the exponent. Did somebody tell you in your past that calculus was complicated or something?
Yeah.
Well, it's not.
Oh, wait, but then you add the exponent back to the thing.
No. What's my exponent?
2. So then
Minus 1 is what?
1.
So that gives me x to the 1, which is just plain old what?
X.
So the derivative is 2x.
Oh, so you just put it back in.
Yeah.
The X. Oh.
Okay.
So then you subtract 1 from the exponent and put the variable into the next.
If it's still, yeah, there's still 1 left. Okay. Let's do some more. Okay. Look at number 4. F of x equals 10. Therefore, f prime of x equals what?
0.
Why 0? Because 10 is a constant. Constant.
Yeah.
That thing.
Yeah.
Look at 6. F of x equals 3x to the 8 plus 5x. For some reason, students find this easier as the numbers get bigger. I don't know why. It's weird. All right, now look. How many terms do I have there?
2.
So that means I have to do each one independently.
Okay.
Okay? So, f prime of x equals 8 times 3 gives me what? X to this 8 minus 1 is x to the 7.
And then plus.
Plus, what the exponent is a 1, so 1 times 5 is what? 5. 1 minus 1 is x to the 0, so what happens to x to the 0? Turns into a 1, so in other words, the derivative of x is just 1. So there is no x on that one. If you have anything less than a 2, there's not going to be anything left when you subtract 1 from it, right? Does that make sense?
Wait, so if x to the 1, then it becomes still going to come x to the 0?
Yes, it becomes x to the 0, but x to the 0 is 1, and you don't write the 1, right?
Which is fine. Then you go
Okay?
5. Okay. That's the
Yeah? Look at number 8. F of x equals 7 minus 0.15x.
That's ugly.
Oh, no, it's easy.
which is just 0.
F prime of x equals, derivative of 7 is 0, so it's gone. What's the exponent? 1 times negative 0.15 is negative 0.15. X to the 1 minus 1 is x to the 0. In other words, it's gone. So there's your derivative. They made it look ugly, but it really is super easy, isn't it?
I still think it's ugly.
Still think it's ugly? You just don't like that number.
Yeah, I just don't like these numbers.
Okay?
What do you put for, if it's, there's fx there, what do you put for y if you want to like d, if y
Yeah, if they gave it to you as y equals something, then you put dy dx.
But why do we need to know how to do the prime function?
Why are we finding the differential?
Yeah.
It gives you the equation of the slope, but in this case, this one just gave me a number, so that means the slope of this line is negative 0.15. But here, whatever number I put in there, I would find the slope at that particular point, where x is whatever that particular point is. We'll find out why, yeah, but that's why. You're finding the slope. Okay?
just to check the y.
How about we do number...
Or one of the ones with the y in front.
How come they give me a... Okay. They only do that for odd number ones. How about number 24?
Oh, that's far.
24.
What? This
These are so fast and easy. Y equals 7 minus 3x to the second power. Because it's got me something I need to show you anyway. Okay. You must, if you have a bracket, you need to expand the bracket first. Okay? Now, in this one, it wouldn't really make as much difference, but if you had a coefficient or anything, it does, so just expand the bracket. So that's the same as y equals what?
49 minus
49
9x squared.
Oh, so you
minus 21x minus another 21x plus 9x squared.
Like that. Whoops, I forgot.
Combine your like terms. Y equals 49 minus 42x's plus 9x squared.
Yeah.
Oh, that's
Ugly. I like the emphasis on that.
Hold on. That's binomial expansion, kids. That's like algebra second day. Okay. So
The whole algebra topic on like this.
dy dx, and we actually did a whole page of expanding brackets. Do you remember that? No? The derivative of 49 is what?
0.
Negative 42x to the first. So since it's an x to the first, it's just going to be, the derivative is just negative 42. Because x to the first becomes x to the 0, which is 1. So who cares? Now this one we actually have to do some work. 2 times 9 is 18. X to the 2 minus 1 is x to the first.
Yeah. So it's just
Cleaning it up, dy dx is negative 42 plus 18x.
So if you have like a one that's just like a number and a singular x that's not like to any power, it ends up just being like the number itself without the x. Is it?
So in the back of the book, they're always going to put it in descending order. The x term comes first. It wouldn't count wrong if you didn't, though. Okay?
You don't have to do anything with like the dy over dx now, right? You just like
No,
say
that's just telling you that that's not the original function. That's the derivative of it.
yeah. And so f prime x and dy over dx are exactly the same thing, just written differently.
Yeah, exactly. If I was doing this, I wouldn't write dy dx. I would write y prime.
Do you have to put y prime x?
Function was
Oh, yeah.
the function was defined in y. I took the derivative, so that's y prime to me.
Also, why does the prime go before the x and not after the x if x it's not 2?
Because you're taking the derivative of the function, not the x.
What is that?
12 or 14.
Okay, 12 or 14?
Yeah.
Ah, okay, good. Yeah, that's a good one. So, like number 12, f of x, good job, good spotted, is x to the 4th over 5 plus 2x. Now, anytime you have a fraction, it's better if you pull the fraction out first. So what number's in front of that x? So that's the same as saying 1/5 x to the 4th plus 2x. Do you see how I pull the fraction in front and drop the x over to the side? That notation works better when you're taking the derivative of it. Okay? So now let's take the derivative. First, it's the 4 times 1/5, which is just 4/5, right? When you multiply, because you put it over 1 and nothing will reduce. So that's going to be 4/5. It's x to the 4 minus 1, which is x to the what? 3. Plus, the exponent there's a 1. 1 times 2 is 2, right? And x to the 1 minus 1 is x to the 0. In other words, turns into a 1, so I need to write it. There you go.
Yay.
Looking better?
Yeah. So then the other one is 1.
Y'all are funny. I guess I usually just don't have deep thinkers.
It lasts.
I usually just have people that go, okay, I can subtract a 1 from a 1 and make a, and I mean I can accept the fact that that x goes away.
Teacher's word is that God. Like I'm just saying zero.
Okay, it just sounds scary. So if you have one fraction with two numerators, change it into two fractions, then take the derivative.
Yeah.
Okay?